Hello, and welcome to Retro Tech Repair. When I was growing up in the 1970s and the 1980s, I was fascinated with electronics, and nothing fascinated me more than speech synthesis. Of course, Texas Instruments were the pioneers of this, and the great product that they had at the time that I really wanted was the Speak and Spell. Unfortunately, even today, Speak and Spells can be quite expensive, so I have what I hope is the next best thing. It's the Texas Instruments Speak and Math. Let's get it repaired and see how it plays. So let's take a quick look at the eBay listing. Vintage Speak and Math Texas Instruments, not working spares or repairs. I paid $6.99 including free postage. In cosmetically okay condition for its age, the battery compartment is missing the clip used to open it, but can be opened with a pen or butter knife, scissors, etc. Pre-owned in what I would call good condition. Thanks for looking, check out my other items. And here it is. It's not in bad cosmetic condition. There is a little bit of yellowing on it, there's some scratches on the screen. It's really pretty consistent with what you'd expect from something of the age. As the seller says, the battery compartment clip is broken, but I think we should try putting some batteries in it and see if he's right otherwise and that it isn't working. And then once we've confirmed it's not working, we'll open it up and see what's wrong with it. So I don't have the butter knife that he suggested, but these seem to work just fine. And I think it takes C-cell batteries. And on! Nothing. Nothing at all. Completely dead. Good. Well, that's what we like to see. Let's take a look inside. So as I record this voiceover, I do have a bit of a cold, so I hope you'll accept my apologies if that comes out on the audio. It took me a couple of minutes to get into the Speak and Spell. There are no screws on the unit and it's held in place by plastic clips which are moulded into the front enclosure and engage in holes in the back of the unit. The knack seems to be to disengage one of the clips using a screwdriver and then move round the remaining clips, making sure that the ones you've already released don't re-engage in the process. After a few minutes I was able to open up the unit and take a look at what's inside. Alright, so we're inside. We have our speaker, obviously. Looks like this printed circuit board is heat staked in place rather than screwed in place. Battery terminals are clean though, so whatever the problem is, it certainly isn't that. I thought at first it was like a heat stake or melted in place, but I don't think it is. Alright, so now I want to get these out. I do like to get the electronics free of the plastics. It just makes repairing so much easier when you don't have to work around the enclosure. Just prizing these out of the way. This feels like it's much later than some of the other games I've repaired. You know, it has just this sense of mass-produced economy that the other games that I've repaired don't have. You know, it just kind of has that feel about it. The absence of screws, the fact things clip together. It certainly has a mass production kind of feel. And again, we have a speaker in here, which try and be careful about that. Make sure that doesn't get damaged during the repair because they really are fragile things with the paper cones there. So I think maybe I will just unsolder that. I don't know if there's any polarity associated with those, probably not. So let's try and bring this over this way so we can see what's going on with this keyboard. It's like a flex PCA in there, but it does seem to be a friction fit. I'd really like to get that connector cleaned up. There we are. It came out. Alright, so this is a neat little printed circuit assembly. Let's zoom in on that. So what do we have here? Well, we have this little board here with the 3 transistors on. These 4 transistors on. I don't see any damage on them. These were 2 with the coloured stripes. I haven't seen that before. I'm not sure what they are. It's interesting to see this nice little VFD display. It still has the, it still has the getter compound on there. So that looks like that's intact. And we have our processing IC, another couple of ICs. Looks like there's a poor solder joint there on that resistor, but I don't see that that would be a problem. Workmanship isn't great. This particular chip is one example. It's not set there. It's not set very straight in the assembly there. So I'm actually more intrigued by this keyboard and whether this keyboard is working. So I've been taking a look at this printed circuit assembly and I've been taking a look online to see if I could find a schematic or a service manual for the Speak and Math, and I cannot. I did find a schematic for the Speak and Spell, but it's from a different version to this. I assume an earlier version, and so it's very limited use really. I think we have a processor maybe some speech ROM here, or a speech processor and some ROM. I'm not sure. So I think this is a power supply module. So a couple of possible causes for this not turning on that I could see are either we have some problem in the power supply, and these look to be good contacts. I'm sure we're getting 5 or 6 volts as it should be onto the board. So I'm thinking we either have some problem with this power supply, or we have some problem with our keyboard. And of course, this is a membrane keyboard. I don't see any wear on it, and honestly, I've seen Speak and Spells that are much more worn than this appears that work. The keyboard works fine, but I haven't easily managed to connect connectors to here and press on here. It's kind of difficult to do that. I don't think there's any active components in here. So basically this is just a matrix where we're connecting one of these to the other. So when you press a key like that, it's going to connect 2 of those pins together, I assume. So if I were to connect 2 of those pins together manually, then sooner or later I should find the pin that corresponds to the on switch. And if that works and I can't turn it on with the keypad, then there's a good chance that in fact the keypad is at fault now. Probably won't be able to fix that, but we can at least satisfy ourselves that that was the problem. So since I think that when you press a button on here, all you're really doing is connecting 2 of these pins together, right, whichever one it is in a kind of matrix, then my theory is that I should be able to simulate that by connecting pins together on here. I don't think there's any active components in here, so I don't think I'm going to do any harm. I think these are just connections, just one to the next. So what I'm going to do is I'm going to hook this up to some power, and then I'm going to try bridging across each of these with a piece of wire, and we'll see if we can simulate what the on button is on here and get this to spring into life. So to do that, I have a 6 volt power supply here. It's a bench power supply, but it's set to 6 volts. And I've got the current down fairly low, so that if this runs away or something, there won't be too much current before the power supply shuts off. What I'm going to do is I'm going to take the probes from my multimeter here. There we are. And I'm just going to temporarily put a little crocodile clip in there just to hold these 2 together. So essentially now what I have are 2 probes that I can kind of probe around in the game with, which are connected together in a loop. I'm now going to use these to move along our board here and see if I can simulate the pressing of the on button. So I'm just going to start on the first pin and work my way across. Nothing there, and then the next one. I'm starting to run out of hope a bit because I'm running out of pins. Oh, well, something happened there. There we go, I think that's it. Pretty well can't see that in the bright lights. Let me dim the lights here. Okay, there we go. Excellent. All right, so let's see if the sound's working. Rather than me have to temporarily resolder everything back together, we'll just put a couple of jumper leads on here. Okay, so I think we've got everything hooked up now. We have the speaker hooked up, we've got the power hooked up to our bench power supply, we're going to turn it on, and then we're going to connect pins 1 and 6. And we're going to see if our Speak and Spell has anything, or Speak and Math has anything to say. Brilliant. So we now know that this board actually works and the speaker and everything works. So we have to turn our attention to the keyboard, which to be honest might be a tricky fix, but let's take a look anyway. Okay, so I have my multimeter now set to 200 ohm range, and I have it clipped onto the correct pins 1 and 6 of this ribbon cable which comes from the keyboard. And no matter what button I press on the keyboard, when I press on, nothing happens, there's no continuity there. And when I press any of the other, oh, some of them work. Oh, looks like I got some of them working, maybe. That's good. Good, got some of the buttons working, but nothing on the on button. The on button, no matter how hard I press, doesn't work. And I have connected this back up onto the board just in case there's some oxidization on the contacts or something, and it still doesn't work. So unfortunately, I think we have a problem with this membrane, and I don't know if I'm going to be able to repair a membrane on something like this. It's glued on, and I honestly don't know if it's going to be repairable. I know that the electronics works. I know that the keyboard doesn't work now, and unfortunately the keyboard is bonded to the case, and I don't know I'm going to be able to repair that. I looked online, I've Googled around, I don't see anybody who's repaired these keyboards successfully. I don't hear any instructions on how to remove it. When I look at it, I don't see any broken tracks or anything like that. So the only thing really that I can think to do now is just to try and remove this myself and see if there's anything I can get to that might repair it. But I mean, realistically, I think probably I'm not going to be able to do that without destroying the speaker math. So unfortunately for this little game, its days are at an end. But nonetheless, we'll see if we can figure out what's going on with this keyboard, and at least we'll know what the cause of the problem was to our satisfaction. So what I'm going to do is I'm just going to lift the edge of this with a knife just to kind of get initially beneath it, and then I'm going to try and, once I've kind of nudged it up, try and gently, really gently kind of smush it back, and then maybe we'll apply just a little heat to this as well, see if we can soften the glue some. So as I gently peel back the keyboard, I wanted to take a second to thank everybody who's gone to the trouble of subscribing to the channel or leaving comments against the videos. Your feedback is very important to me, and it really does make a big difference to learn what I could do better, differently, and what elements of the video you enjoyed. I'm genuinely excited to get every new subscriber, and I do check out the subscribers' channels and see what's going on with them and YouTube. I've found some really interesting content out there that way, and I've subscribed to a number of new and exciting channels I wouldn't have seen otherwise. So if you'd like to see more videos like this, please do click like, share, and subscribe. Now, let's return to our repair. Here we have our speaker math keyboard and a naked speaker math. It actually came off quite nicely. I'm quite pleasantly surprised by that. The front piece seems to have these tracks on, and then there is a second piece, a top piece, this separate piece here. Looks like it comes away a little. I'm probably going to try and lift that off in a minute. That has additional tracks on it, and then it looks like maybe there's a third layer in between which holds that front piece and the back piece apart, so that only when you apply some pressure does it bridge those two and make the two join together. So I'm just going to pause the camera a second and take a little bit of a closer look at this. So looking at this again, I think actually maybe this piece folds over. It's kind of folded around, but so look at these tracks at the bottom. So I think the back piece, the tracks on the back piece here come down, they go around the corner here, and I wonder if that may be where some of the damage has happened, and then back onto here. So, and then there's one piece in between which is just kind of holds the two apart until you press the button. I'm going to see if I can peel that back and see what is going on with this keypad. So looking now at our speaker math keyboard, now we've got the two separated. This is the connector that goes into the game. It's on the clear substrate here, and there's a number of lines run down and to each of the keypads, and then some of them come all the way around and come onto this top surface here. I don't know if you can see that, but that has tracks laid on it also. Let me just move that up to the camera. Okay, so you can see those tracks there, and then there's this other membrane in between the two which just kind of holds these two apart from each other. Normally they're folded up like this, and then when you press on, you kind of push those two together and that makes the contact. So if I look at the connector as I had it, 1, 2, 3, 4, 5, 6, move over to my pin 6, put my continuity tester on there, and move over to my power switch. So I have power. Now what I need to do is I need to look at the track that comes down on this to make up the circuit. And as I look at that, that is this track here, and this track here runs all the way around the outside, and then around the outside here, around the outside here, and comes up to be this pin. And so I put my continuity tester on there, and I go to here, and I have no continuity. And in fact, if I go to here, I have no continuity. Only here do I start to see some resistance. And when I look at this keyboard membrane, what I see is there was a piece of tape here, and I thought actually this was just dirt, but when I look at it, I think that line there has worn away somehow. So what I need to do now is somehow get this cleaned off and that line there remade. Now, of course, what that means, unfortunately, is that all this effort I spent folding back this keyboard here was wasted, because actually the problem lies outside of there, so I probably have checked that first, but I didn't. And so I think now if we get this cleaned up somehow and get those lines remade, we should be good. Okay, so I folded our keyboard back over. It's still, as you can see, only loosely attached there. The glue at the bottom seemed to tape, the glue around the side didn't. If we get this repaired, I might put some double-sided tape or something on there just to kind of hold that in place. I'm now going to take a look at our damaged tracks here, or this particular damaged track. All the rest look good. I'm going to try and clean off some of the adhesive with alcohol. Now, I don't know if that's a good idea, because I might actually bring the track with it as well. So I'm just going to concentrate at the moment on the area that appears to be damaged. I looked at the rest of the other tracks and they all look good. It's just this one here that does look to, well, clearly, you can see that, clearly that track has gone. The rest of them look just fine, but that one has gone completely. So the way that I'm going to try and repair this track here is with this silver conductive paint. And this paint, I haven't used it before. I don't endorse it or anything like that. It might be great, might not, I don't know. But it does come with a whole big raft of warnings. Highly flammable, use only outdoors, causes eye irritation, drowsiness, dizziness, danger to aquatic life, and many other things. Highly flammable. So if you are going to use anything like this, please, read the instructions. And the fact that I may not have followed all of those, that's just what I have chosen to do. If you do anything like this, it's entirely at your own risk. So just follow those instructions carefully. So like I say, I haven't used this before. I'm going to try and get the flow of ink going here, or paint as it is, I think. Pressing on the tip, and then I'm going to try and draw this one track in place where it's failed. It's not a precision tool, at least not in my hands. If I was doing this elsewhere, it wasn't the last track, I'd need to mask this off, I think. Maybe I'll just put a little bit more on since I can. So here it is, like I say, it was the end track, so I was able to, go over the edge there. If it had been a middle track, I'd have had to mask that off. Okay, so we need to get this membrane stuck back now, and I think I'm going to use some double-sided tape to do that. But at the bottom, it seems to be pretty well stuck. I don't feel a need to put anything else there, but I'm going to put some more around the edges here. Well, I think we should now plug this in and see if it works. All right, it's the moment of truth. Great. Let's zoom in. Hopefully you can see this. Make sure our power off button works and our power on button. And we'll do a couple of games just so we can try out the keypad.
9 plus 0 is what?
Well, obviously it's 9, but let's do some different numbers. So at this point I went on to test the rest of the keyboard, playing various games and functions on the speaker math. But when I came to edit the video I found the footage quite dull, so I've decided to take a different approach. Rather than take you through the tedium of watching me press every key on the keyboard, I've decided instead to show you the reassembly of the game. And while I'm doing that I'll have the speaker math voice playing in the background. So what you're about to see is me reassembling the game and reattaching the keyboard. You could effect this repair probably without removing the keyboard. This was just an error on my part, and as I say, I'm not an expert in these repairs. So for the remainder of this sequence I'm going to let the speaker math do the talking.
0 plus 2 is what? Write it level 1. Greater than, less than, level 1. 25 plus 5 is greater than or less than 29. 5
And that just about wraps it up for our Speaker Maths today. An interesting repair. I hope you've enjoyed the video and I hope you found it useful. I'm going to go ahead and dim the lights a little and play the game, and in the meantime I'd like to thank you so much for watching Retro Tech Repair.
Solved level 1.